Dear viewers and subscriber, thanks again to watch our YouTube channel Max the Service. Max Service is the only YouTube channel to take care of providing videos with proper information like documentation, architecture discussions, and working with practical examples for beginners and expert to learn by watching videos on Max the Service YouTube channel and start leading in the industry.
Okay, guys, in last session we briefly discussed Docker outline, and today we will start our second session on Docker, and we will be discussing in this session introduction, and under introduction we will discuss all these topics: what is Docker, why it is popular, why when to use Docker, traditional and new approaches to use Docker, importance of Dockers, benefits, alternative, and all use cases apart from feature, disadvantage, advantages and disadvantages of Docker. So let's start first with introduction, and let's see what is Docker. Okay, Docker is open source containerization platform by which you can pack your application and all its dependencies into a standardized unit called a container. Containers are lightweight, which makes them portable, and they are isolated from the underlying infrastructure and from each other container. You can run the Docker image as a Docker container in any machine where Docker is installed without depending on the operating system. So guys, here we have number of things. What first is containerization, and second is uh, lightweight and portable, and third is image, okay, and fourth is depending on operating system, installed without depending on operating system. So let me describe one by one with some graphical presentation. In this image, it is simple and easy to understand. In left side from dev, you can see that any development team and operation we have get developed, and it is become an application with different languages, database, node server, Ruby, Java, whatever language you have used. All those dependencies and libraries, after developing, testing, now it is available as a standalone app which can be deployed, which can be installed on anywhere to run. The containerization term used in this video, actually, when you think that okay, there is number of things related to each other, and we don't want to uh, do the things again and again. Let's suppose you are working on Windows, and then you are going to start running your application on Linux. Then definitely you have to download all the dependencies, you have to check your integrations, you have to install database, and you have to check also database configuration and connection with your application. But once you do your that application as a container, then those container can be portable, those container can be duplicate, and those container can be uh, run anywhere. So in the right side you can see it can be run on Windows or Linux or anywhere in cloud, in your on premises, and it can be connected with any other application. Here the question is how this application becomes as a container, run as a container. Actually, there is a file, Docker file you used in your application, where you do some configuration, do some settings, and then you run some commands to build that application as an image, that is called Docker image. once your application is available as an image, and then when you start running your image, it runs and available as a container. So you can also move that image anywhere to start as a container. So it is very simple. So let's see another aspect why Docker is popular. To measure its popularity, here are few things to consider. One is portability. What does it mean? Once you have image, you can move anywhere and run as a container. Reproducibility. Once you packaged all dependencies as a image, it will remain consistent across all the environments. Even you are in QA, dev or production, you don't need to do extra thing. You don't need to do download, add, integrate anything what you already have done. So reproducibility is zero. Efficiency, you can run multiple application on a single host system. So in any requirement to make different application, more than one application, you can just multiple instance, you can run multiple instances at the same time. And scalability, on the base of your need, if you can increase and decrease your images and run as a container, so it's a very good benefit. Okay guys, if we discuss the approaches of development and deployment of application, so there are three different ways. In start, we just use only one operating system to deploy a whole application, right? Then the concept become of virtual machines, where we virtualize our operating system. We can create guest operating system, like here in left image you can see guest OS, guest OS, guest OS. Now we have one operating system, one machine, and we divided that one machine into three guest operating systems. Okay. So for that, to deploy number of application to avoid conflict between these, we must virtualize our operating system, and now we have virtually three operating system to run the application A, application and application B. But when we come with the approach of Docker and containerization approach, here in right image you can see that there is only one container in a engine, and then you can share your binaries, your libraries, your dependencies with more than one application. Let's say you can see here we have two application running A, but with same libraries and dependencies. Why? Because we containerized, we build an image, and now we can use multiple instances, and we don't need to virtualize operating system, we don't need to make configuration, setup and download and install everything for each application. Just we can start with already built image, and we can run as a container more than one application. So this is the major benefit and uh, tradition of enhancement in development and deployment of application. Guys, here are alternatives of Docker. We will also do some sessions on all of these after Docker. So here is Podman, RKT, Linux container, and uh, another is Containerd. So we will discuss later on it. So here you can go through its definition, and we will also discuss in detail why we can go other than Docker to choose any one of these options. Guys, whenever we choose any tools and technology, definitely we have to go through the requirement, and we have to understand the use case whatever we are going to achieve or implement according to our business case. So Docker, first important use case to use Docker is to go with the CI/CD pipeline, where you need continuous integration and continuous deployment. Here is just you have to configure a file with some settings and instruction, and where you will be automatically build image, and it will be image will be run as a container on the set environment, either is it a QA testing or development, either production. So another important use case is microservice architecture, because when we go with microservice architecture, definitely we have to scale up and scale down. You have to utilize number of instances. You have to implement some securities. You have to go with the integration and communication between instances. So all of these achievement can be easily done when you go with Docker and containerization. Okay, the third important use case is to go with the development environment consistency. Okay, it is third and important. Another use case, it will ensure with consistent deployment, testing, and production environment. It actually reduce the works on my machine issues. Okay, actually when all of these can be done with GitHub Action, GitLab, or there are number of technologies available. So last use case is also important, which is multi-cloud and hybrid cloud deployments. Okay, sometimes you also need some uh, different deployment, different cloud, like you may have hybrid environment, you have pure cloud environment, you might be deploying running images as a container on your on premises and some of on cloud. So all of these concerns are covered when you go with Docker. Okay guys, let's discuss some features of Docker, which is one of the important is open source platform. Open source platform is a very good feature where you can integrate, you can go with different technologies, tools and technology you can use. So it is very good benefit. Another is easy, lightweight, and consistent way of delivery of application. These features allow us to we have studied and we have seen in previous discussion that it is portable, and we can have consistency within the libraries and dependency within the same image, and we can we can run in any environment, we can move from one environment to another, we can also move from one operating system to other. So fast and efficient development life cycle. It is fast and efficient because once we have configure your Docker file, then you can do your development fast. You don't need to integrate, don't need to download, and you don't need to every time whatever your application need all those tools and technologies every time. So segregation of duties mean this reduces the possibility of work in the development, but now an operations issue. Service oriented architecture. Docker also supports service oriented and microservice architecture. Docker suggests that each container runs only one application or process. This encourages to use of the distributed application model, in which an application or service is represented by a collection of interconnected containers. This greatly simplifies the distribution, scaling, debugging, and inspection of your application. Security. Security management feature of Docker saves secrets into the swarm itself. Docker containers provide a high level of isolation between different applications, preventing them from interacting with or affecting each other. This makes them a secure and stable platform for running multiple applications on a single host. Scalability. The platform is easily scalable as Docker containers are lightweight. The portability of Docker also makes it simple and dynamically manage workloads. Scaling up or down apps and services are business demand in near real time. Docker provides a simple and intuitive command line interface that make it easy to create, manage and deploy containers. Reduction in size. Docker offers a great degree of capacity to minimize development size. The rationale for this is that it may deliver a reduced operating system footprint via containers. Next is image management. Docker uses images to store the necessary files and dependencies needed to run applications. These images are created using a Docker file, which is a set of instructions that tells Docker how to build the image. Developers can use these images to create new containers or update existing ones. Docker also has a registry called Docker Hub, which is central repository for storing and sharing images. Second last is networking. Docker allows developers to easily connect containers and services using its built-in networking capabilities. It supports the creation of virtual networks and allow developers to specify which container can communicate with each other. Ooh, great. This makes it easy to set up and manage complex microservices architecture. Last feature is volume management, which is very important to go through and understand. Docker provides a volume management system that allows developers to persist data generated by containers. This is useful for applications that require a database or other data storage. Docker volumes are stored on the host system and can be shared between containers. So guys, we will go all these with all these features practically. What we have theoretically we have discussed in this session, I assure you I will prove, I will go with some example and everything we will be doing practically so that you will realize whatever is on the Docker documentation, we can go through and we can do some practice and we can understand with some practical example. So guys, this was a theoretical session, and next we will be discussing an architecture, how the architecture flows, component of architecture, the purpose of every component and working of every component, how it works. We will be going step by step.